So that's reassuring that at least my system isn't broke.
Yeah, that sucked for finals week.
Especially look at my finals week here. I got appointments through 9:30 tonight and almost the same tomorrow night. All right, so what are we doing tonight?
Can we go over the inverse sine, cosine, tangent stuff?
Sure. You got some problems?
No. My teacher didn't give us problems because it's snow day, but
Here's the most important thing to know. That is true, right?
yeah.
You take the trig function of angles to get ratios. You take inverse trig functions of ratios to get angles.
All right.
In other words, if I gave you a triangle and I said, tell me what theta is, well, you would see that the sine of theta equals 1/2. So I must have to take the inverse sine of 1/2 to figure out what theta is.
All right.
Well, if you look in your calculator, the inverse sine of 1/2 is 30 degrees.
All right.
So that's all it is. You use inverse trig functions when you're trying to find angles. Use trig functions when you're trying to find ratios. And that's an important distinction. And it's good to make that distinction while everything's still in degrees and ratios. Because the moment you go to radians, this angle actually becomes a number. And then I can't talk about it in the same way. So I prefer to leave it in degrees when we're talking inverse. Because the most important thing to know is that when you take inverse trig functions, you're finding angles. You're taking them of ratios.
All right.
And determining angles. So let me give you a question. If I had a 3, 4, 5 triangle, what's theta? We hear about 3, 4, 5 triangles all the time. Does anybody ever tell you what that theta is?
Isn't it 30?
No. Give me the inverse trig function that allows you to figure it out.
So it'd be sine of 3/5.
Yeah, you can either call that arc sine or inverse sine.
Okay.
You have your calculator in front of you?
No, should I go run up and grab it?
Always.
Okay.
Whenever we're doing a session, you need your calculator in front of you.
Yeah, I've been dealing with my phone since noon, so. Yeah. All right.
Okay.
Yeah.
So look up the inverse sine of 3/5.
I got 0.645, but that's not.
Make sure your calculator's in degrees, not radian mode.
That's why.
37 and change or 36 and change?
Yeah, 36.86.
Okay, now you know what that angle is. Who knows what that angle is? Nobody does. Nobody ever talks about that angle.
Yeah.
But you can figure it out using an inverse trig function. And no matter what triangle or dimensions I give you, you can always figure out the thetas by the inverse trig functions.
Okay.
Now, there is one thing I should say. The inverse sine of 3/5 actually has two answers in the unit circle, does it not? In other words,
Yeah.
also the second quadrant. If you take the sine of 143 degrees, you'll get 3/5, and it'll be positive 3/5.
All right.
Okay? What's going on is that your calculator only gives you the principal value when it does inverse trig functions. In other words, it only gives you the first quadrant angle. It does not give you the second quadrant answer. And if I had the inverse sine of negative 3/5, it's going to give you the fourth quadrant answer, not the third quadrant. Even though the third quadrant is just as valid as the fourth, your calculator doesn't show it to you. Your calculator, it's important to know that your calculator is not giving you all the answers in the first unit circle. They're not giving you all the answers between 0 and 2 pi. It's only giving you the first quadrant answer. You have to know that the second quadrant answer is also a possible answer. Just like if I had this one, it would actually give me minus 37 degrees, but that's fourth quadrant.
Yeah.
But it would not give me the third quadrant answer. I have to figure that one out myself. So just know that your inverse trig functions only give you half of the real answer. And it's called the principal one. For sine, if this is positive, you're going to get a first quadrant answer. If it's negative, you're going to get a fourth quadrant answer. For cosine, if I'm doing cosine of some value, if it's positive, I'm going to get a first quadrant answer. If it's negative, I am going to get what? Which quadrant?
A second quadrant?
Yeah, that's the principal quadrant for negatives in cosine. Sine is going to be first and fourth for positives and negatives, but cosine is going to be first and second. Tangent would be first and fourth.
First and third.
No? By what I mean by that is if I have a tangent of a positive number, it's going to give me the first quadrant only, even though the third quadrant would be a legitimate answer, right? If I'm taking the inverse tangent of minus 1, 45 degrees is correct, but so is 225. But stick that into your calculator and it'll only give you 45.
Yeah.
If I had the inverse tangent of negative 1, it's going to give me the fourth quadrant answer. And it's going to give it to me as a negative. Go ahead and put in inverse tangent of negative 1. Should give you minus 45 degrees.
Yep.
Even though 135 is also correct, right?
Yeah.
I mean, the tangent of 135 is negative 1. So just know that you're only getting half of the answer, but it's called the principal answer. In other words, there is something special about first and fourth quadrant for sine and tangent. And there's something special about first and second quadrant for cosine.
Okay.
Those are the principal quadrants for each of those. All right, what else?
Can you do ones where it's like cosine, parentheses, like tangent, or the inverse tangent?
Yeah. Something like that.
Yeah.
Always start from the inside and work out. So let's figure out what angle they're talking about here. And when we do this, we are only interested in the principal angle, the one your calculator is going to give you. We don't want that second angle.
All right.
So what's the inverse tangent of root 3?
60.
So that's what goes in there, is an angle.
All right.
Now what's cosine of 60?
1/2.
So that's how you do all of those kind of problems. And
Okay.
it is very important when you're doing these type of problems that you use the principal. In other words, I would not want to put in, that was 60 degrees, so 240. That would actually be a legitimate answer to that. But notice that if I use 240, now I get minus 1/2 for the cosine.
All right.
So which answer you use is important. I don't want to use the third quadrant answer here. That's not the principal value. The principal value is the first quadrant answer.
All right.
Now, if you have something simple like this, that's always going to be equal to the number.
All right.
Even if I had this. In other words, we don't even need to know the angle. Right?
Yeah.
I never once figured out what theta was, but I know the sine of the inverse sine of a number is equal to the number.
All right.
Same thing as this. The inverse sine of the sine of theta, well, that's equal to theta. Hold on 1 second. Something's going on with my garage. I'll be back in 2 minutes.
Okay.
Guess maybe some snow on the garage floor got away. It's not halfway. Well, that has to do with the weather. No, I got everything's at home today. Yeah, no, that's fine. Yeah, I know. All right. Mitch?
Yeah.
Sorry about that.
You're good.
Okay. What else?
That's really all that I need to know, because all the other stuff I've been just teaching myself how to do, like, because she's just given us an entire, like, book of review pages, and it's simple for me now, because I taught myself.
Can you solve that equation, or do you have to be able to solve that equation?
Yeah, we do, but
Okay. How do you do it?
Can't you? You don't factor out a sine on that one, do you?
No. Treat it like a quadratic. It looks like a quadratic, does it not?
Yeah.
In other words, you have this term, you have the square of that term, and you have a constant. That's
Yeah.
a quadratic. It's called a
So,
quadratic in sine x.
okay, so
If I had this quadratic, that would be a quadratic in x. This is a quadratic in sine x. So factor it just like you would any algebraic expression.
so sine and sine, 2 sine, and then it would be a
Next step is to
negative.
figure out the signs, both signs.
Yeah, one's positive, one's negative, and
Okay. I have to handle that by doing it this way. Because this coefficient is not the same as this coefficient, plus minus is not the same as minus plus.
yeah,
I have to handle it this way. In other words, I have to allow for a plus minus or a minus plus. Now, there's not very many factors of 1.
yeah.
So we'll just try that. Does that work?
No.
Gives you the right number, but the wrong plus or minus sign, right?
Yeah.
Well, whenever that's the case, just move it to the other side. That's going to give you the same number, but opposite sign. In other words, that will give you a minus 1 as a middle term, minus sine x, rather. Okay, so that's our answer.
Yep.
Now, keep solving it.
So then it would be sine x equals 1.
Where
and
does
then
that occur?
That's the first quadrant, 90 degrees.
Pi over 2, okay. And the second equation is what?
It would be sine 1/2.
Negative 1/2.
Negative 1/2, and
Where
that's.
does that occur? In the unit circle, where does that occur? This one's going to have 2 answers, because there's 2 quadrants where sine is equal to negative 1/2.
Yeah, so it's 3 and 4, which is
Okay.
7 pi over 6 and 11 pi over 6.
Yeah. Good. That's good. I can see you're beginning to think in radians. You didn't answer. I could tell you didn't answer that with degrees and convert to radians. You answered it in radians from the get-go. In other words, x here was pi over 3, or pi over 6 is the angle we're talking about. And then we just have to figure out what is pi over 6 in the third and fourth quadrant, right?
What?
So the answers, there's 3 answers to this equation. Those 3 right there.
All right.
Okay. Have you had to do double angles and half angles and all that stuff?
Yeah, and that stuff's kind of easy for me right now, but it's
Okay.
an entire multiple choice test.
Are you also allowed a cheat sheet? Is she giving you a page that has all the equations on it? I think you said.
Yeah.
Yeah. So you don't have to memorize any of this.
No, the only thing we have to memorize, I think, is the chart for the unit circle.
Okay.
But other than that, and I already have that memorized, so.
So by that they mean
It's the sine, cosine, tangent, cotangent, sine.
what are the coordinates of that point right there?
Isn't it?
This is what you have to memorize, right? The X and Y.
No, it's a chart. It's the chart
Oh, so you just
that has,
memorize what the sine of 30 is.
yeah,
Okay. Well, the X coordinate is the cosine of the angle, and the Y coordinate is the sine of the angle. So the X
okay.
coordinate is root 3 over 2. The Y coordinate is 1/2. I thought they
Yeah.
made you memorize this entire circle, and you were forced to put the coordinates of each like that. In other words, that's for 45 degrees.
Yeah.
But it's worth knowing that for the unit circle, only for the unit circle, the X coordinate is cosine of theta, the Y coordinate is sine of theta.
All right.
All right. You have any other things? I'm going to stop trying to guess what it is you might want to know. And
No, that's the inverse stuff was the only reason I kept this tutor session.
okay.
Is because I totally forgot how to do that.
Yeah, it's just it's the classic definition of inverse,
Yeah.
including its appearance. In other words, if I took the sine and reflect it across the line y equal x, I get the inverse sine curve. I can't reflect the entire curve because then I wouldn't have a function. But if I restrict my reflection to from minus pi over 2 to plus pi over 2, notice that is the first and fourth quadrants, then I can reflect from there to there. That function is 1-to-1 between minus pi over 2 and pi over 2. And when I reflect it, it looks just like something like that. And this is inverse sine. Y equals inverse sine of x. So the inverse trig functions are just like all inverse functions. Graphically, they're reflected over the line y equal x, and so forth and so on. But
All right.
okay. All right, Mitch, you good luck on your test, and have a Merry Christmas and Happy Holidays, and I'll probably talk to you next year.
All right.
All right, bye-bye.
Bye.